All right, get out your notebooks. We're gonna get started. A little bit longer video. Okay, we got some heavy hitters. We got midpoint formula and distance formula, both really important. They're gonna come back over and over. So let's get started. All right, what I want you to do is I want you to come up with 6 line segments that are not congruent and 6 rays that are not congruent. Okay, what I mean by that is that they cannot be the same shape. Okay, PE. If I write PE as a segment, I cannot write EP because that's the same thing, right? If I were to write PE as a ray, okay, starting at P and going through E, it'd be kind of like this, going like that. Because order matters for rays, I could switch the order and say EP. That is a different shape because it's going to the left now instead of to the right. Okay, so you got to be careful. Congruent means they're not the same. All right, so come up with 6 of each, 6 segments, 6 rays. 6 segments can be a little bit tough, so try to brainstorm on that one. All right, I'm gonna list them out. All right, we could have EY. We could have both of them put together, PY. We could have HE. We could have ET. And if you do both of them together, you could do HT. Now, any of these, if you have the order switched, that's the same thing. TH is the same as HT. All right, let's do, there's more than 6 rays because you can switch the order, but we could do EY, and then we could do YE. Let's go to the left, going the other way. You could do HE, and then EH. Okay, go to the right and then to the left. And then there's 2 more. You could do ET and TE. And that would be 2 more, but that's 6. All right, moving on. All right, midpoint and distance formula. That's what we gotta learn today. All right, what is a midpoint? Okay. It is a point. I probably learned to spell. What am I spelling? It is a point that divides a segment into 2 congruent segments. All right, and I usually like to draw a picture, especially for geometry. A picture usually helps. If I have segment XY, and I put Z in the middle here, the only time Z is a midpoint is if it cuts this in half exactly, okay? So let's say that this is 5 inches here. It's not really. And this is 5 inches here. Well, since they're the same, we can say that Z is a midpoint. And I always put a slash through my Z so you know it's not a 2. Now, your book is not going to make it this clear with 5 inches and 5 inches. They're going to use a new symbol. They're going to say, I'll draw this again a little bit smaller. They're going to say that these 2 are congruent, and there's a symbol for that. If I put a dash mark through each of these, that tells me that both of these segments, XZ and ZY, are congruent, okay? It's the same thing as saying they're the same length, but it's just shorthand, so you'll see that quite a bit. Same thing, Z is still a midpoint in this situation here. Segment bisector. It's any shape, so it could be a line, ray, segment. That crosses a segment at its midpoint. At its midpoint. All right, we can draw a picture of this as well. And we could could be any shape, right? So if we have A, B, and we have a line here like this, let's call this line M, and that crosses at C. This is a segment bisector if C is a midpoint, meaning that these both of these halves are congruent. Okay, so we would say that line M is a segment bisector. All right, very good. So we know midpoint, segment bisector. Now we can talk about the formula for midpoint, which speed things up quite a bit. Okay, and this is the same thing, but for your textbook. Notice these red dash marks here. You'll see those a lot. Oh, and they use M for midpoint a lot in the textbook because, you know, that makes sense. All right, so let's say this here. Now, you don't have to draw the picture for these. You can just write down the numbers. Well, let's say, but actually it probably would be nice to draw this picture here with X, segment XY, and segment VW. And let's say that XT is 39.9. So X to T is 39.9. Identify the segment bisector of XY. Then find XY. So when they say identify, they want you to name what type of shape it is, using usually two capital letters. So in this case, we see we have two red dash marks, meaning that this T is our midpoint. And because T is our midpoint, we have a segment bisector, which is this VW. So we have to know what type of shape it is. That's a segment, because that is endpoints. So we would say that it is VW. That's our segment bisector. It's going through the midpoint. So we say VW, and then they want us to find the length of XY, which is pretty straightforward. All we have to do is, this is 39.9 times by 2, and we get our answer. So we get XY equals, and that would be, what would that be? 79.8? Is that right? Yeah, okay. 79.8 centimeters. Okay, so those are pretty straightforward. You just have to know what a midpoint is, and identify means just name the shape. It's segment VW. All right, identify the bisector of PQ, and then find the length. So there's no symbol, the length of PQ. All right, try both these. We got fractions now. Pause it here, do these, and then I'll do them on the board. Okay, so now we have our bisector. Our bisector is going to be this ray here, ray MN. So this is our segment bisector because this is our midpoint. M's our midpoint. And they want us to find the length of PQ. So we do have to add these together. So this is also going to be 1 7/8. So we add them together, and we get PQ. PQ equals 2 14/8. Okay, obviously these 7/8 add together to be more than 1, so we have to simplify that down. So we get 3 6/8. Or you could simplify that down even further to 3 3/4. Okay, make sure you remember how to do fractions. All right, over here, it's a point. So our bisector is point M. And PQ, we just have to double it. This is 2 2/7. So PQ equals 4. We have the fractions separately, so it'll be 4 4/7. And it's not improper, so we can just leave it like that. Okay. And sometimes I'll skip stuff just because I know what they're asking, and we're going to talk about it later. All right, this one here, this is the same thing, except we have unknown values in both of our segments. So they tell us that we have a segment bisector, and they want us to find the full length here. Okay, so first I want to identify it. So I just stop here and draw this picture down because you're going to see this quite a bit. You need to have an example of this. So we're going to identify our segment bisector. Okay, our segment bisector is this ray here. So we'd say that it's, what is it, MN? Ray MN. And then we have to find this length VW. Okay, now we have 4x minus 1 and 3x plus 3. So in order to find that, what we're going to have to do is we're going to have to set these equal. We know that if this is our midpoint, they're equal to each other. So we got 4x minus 1 equals 3x plus 3. Hey, you've probably done something like this before. So we solve this. First thing we do, deal with our constants, then minus 1 and plus 3. So you have some options here. Some people might add the 1, some people might subtract the 3. What I'm going to do is I'm going to add the 1. It's going to be easier later, you'll see why. So I get 4x equals 3x plus 4. So I added the 1 over. Now, I want just x to be on one side, so I'm going to subtract 3x over. So subtract 3x, and I get x equals 4. There's more than one way to do this, all right? But either way, you should end up with x equals 4. All right. So then, oh, we're not done. Sorry, what do they want us to find? They want us to find Vm. So if x equals 4, okay, if x equals 4, then we can plug it back into either of these. Okay, let's just do this here. So let's do 4x minus 1. So it'd be 4 times 4 minus 1, which would equal 15. So if this is 15 here, then this is 15 here. We can double check it. Oh, lights turned off. Come on, lights. Then we can do, it'd be 12 plus 3. We get 15 also. So we can say that Vm equals 30. All right. We'll just do one of these. So let's just do, oh, this one's kind of tricky. Let's do this one together, yeah. All right, so let's do 4 here. It's not too bad, but I can see some people might mess up on this one. All right, so try this one, number 4. All right, first thing we do is we identify our segment bisector, which would be line L. And then we can set these equal. We got 5x minus 3 equals 11 minus 2x. All right, first thing I do is deal with the constants. I can either subtract 11 from both sides or add 3 to both sides. I'm going to add 3 to both sides. So I do 5x equals 14 minus 2x. I want to get rid of this minus 2x, so I have to add 2x to both sides. And if I add 2x, I get 7x equals 14, and x equals 2. I'm not done, because they want us to find MQ. So I got to plug this back in. If I plug this back in, I get 2 times 2 is 4. 11 minus 4 gives us 7. And let's just double check the same thing over here. We do 2 times 5, which is 10, minus 3 is also 7. And we get MQ. Oh no, sorry, they just want MQ, they don't want the full thing. MQ, this here, would just be 7. That's why it's important to read what they want. Okay? I don't expect you to show this much work, and I'm willing to bet some people messed up. If you subtract 11 over instead, you get negative 14, and then you subtract 5 over, you get negative 7x. The negatives cancel out when you do negative 14 divided by negative 7. You should end up with positive 2 again. All right, we're going to skip 5 here. All right, you guys can try this one. Not really stickler on this. If you want to just look at this, you can. But it is kind of cool to see. You can make a midpoint without any measurements. Obviously, a ruler could do this too. But if you make 2 points and you fold the paper so A and B touch, then you would get where the crease is, that would be your midpoint. Okay? So you can make it, and before they had like standardized measurements, this is the way they had to do things. They had to have tricks to make sure things were exact. I'm talking like way old, like the BC days, before we had modern day measurements. All right, now we're into the big dogs. We're into the midpoint formula, and all right, we'll just talk about it. Okay. So let's say that we have 2 points, okay, and it's on a grid. Okay, so we're on an XY axis, and we know the coordinates of these points. Okay, so let's say that point A, and just to make it general, we could say it's like 1, 2, but let's just say this is x1, y1. And some of you guys have probably seen this before. And then we'll say that point B is x2, Okay? All right, if we have midpoint formula, basically what this is asking is if we have 2 points, A and B, where is this point in the middle? Right here, M. All right, so what we can do is there's a shortcut, okay? You could count the spaces on a graph and figure out where halfway is. That works just fine. But there is a shortcut that works pretty well, okay? And it looks like this. Our midpoint is going to equal x1 plus x2 over 2. Now, it's important to understand what is happening here, okay? We are taking the average of the x values, okay? We're taking, adding these two together and dividing by 2, so we're finding what is exactly in between in the x direction. Remember, this is my x-axis, and this is my y-axis. Okay, hopefully you remember that. So we're finding in the x direction what is exactly halfway between. That's going to be the first number of my point. Remember, midpoint is a point, okay? So that's my first value. I just add them together, divide by 2. For the y direction, I'm going to add the y values together and divide by 2. Find the average, or what's halfway between the two y values. So y1 plus y2 over 2, and that's going to be my midpoint formula. Essentially find the average of the left and right, the x-axis, and the average of the up and down, the y-axis. Okay? I think I have an example here. Oh yeah, here we go. Okay, so we have this here. So write down this example. This is a good one. I want to find the coordinates. Now, oftentimes you're asked to do this without a graph. If you want to get a piece of graph paper, plot them, and find what's halfway between, you can always do that. I'm just showing you that you don't need to. There's a really good shortcut that you can always do for midpoint. All right, so we've got R and S, and we've got, oh, and they even graph it down here. Okay, so we've got R and S. So R is over 1 down 3, and S is over 4 up 2. Okay, so without, we can kind of get an idea of what it should be, but without graphing it, we can figure this out. So we've got, our answer should be, and I wish I had this, maybe I'll just copy this here. Yeah, maybe I'll just copy this over. Don't mind me. Oh, that is not what I wanted to copy. Try to be quick here. All right, yeah, let's copy this over so maybe we can look at it. All right, we've got our midpoint formula, and we've got our points here. Okay, so for our midpoint formula, this is our first point here. Our first point is this point R. So this, for R, this is going to be our x1, and this is going to be our y1. Okay, because that's our first point. You can switch the order, it'll still work out the same. Okay? This right here is going to be our x2 and y2, because it's our second point. So, okay, x1. x1 is our first x value, so it'll be 1. So it'll be 1 plus our second x value, which is 4. So it'll be 1 plus 4 over 2. All right, done with that. Now we want to look at the y values, our second number in each point. So y1 is -3, and the other number is 2. So -3 plus 2 divided by 2. All right, this is our point. So all we have to do is figure out these values, and we have our midpoint. And you should be able to look at this picture and make sense of it. It shouldn't be like way off the graph. It should be exactly what you're expecting. Okay, 1 plus 4 divided by 2. So basically 5 divided by 2, well, that's 2.5. So you can say 2.5, that's fine. All right, -3 plus 2, that's -1 divided by 2, well, that's -0.5. So we could write that as -0.5. I'm sure some of you guys wrote this as 2.5 and -0.5. That's the same thing, okay? Anyways, this is our midpoint. And you can count the spaces and say, oh, it's over 3, so I should go 1.5. it's the same thing, okay? I'm not gonna say you can't do it that way. But this is our midpoint, 2.5 and negative 1/2. So we go over 2.5, down 1.5, or down 1/2. Okay? So that's midpoint formula. I want you to try, I want you to try this JK one. See how that goes, all right? And there's no picture with it, so you kind of have to, use the equation, or you could grab some graph paper and graph it and see where it ends up. All right, so try that, and I'll write it up here as well. All right, so my x1 is 2. So I'll just label them up here. This is my x1, this is my y1, x2, y2. So I've got 2 plus 1 over 2. And then I've got 1 plus 4 over 2. All right, now I can just simplify that down, and I get 3 over 2. And I'll write this as a fraction. You can do fraction or decimal, same thing. 3 over 2 and 5 over 2. And that would be your answer. Or I'm sure a lot of guys wrote this as 1.5 and 2.5. It's the same thing. Okay, you can write as a fraction or decimal, doesn't matter to me. Okay, this video is getting kind of long, so I think I'm gonna split it into 2 parts. I think that is the plan. That's midpoint formula. Where was I? Yeah, so let's wrap it up with this last one here, and then we'll do distance formula next time. So all I want you to do is, let's not do 6, let's do those negatives. So try number 7, find the coordinates of the midpoint. Like I said, you can do graph paper, but try to do it with the equation, okay? So try 7, and then we'll pick it up with distance formula next time. All right, so we got negative 4 plus negative 6 over 2, and then we've got, let's probably on this side is my x1, y1, x2, y2. Okay, so just plug it in. And then I got 3 plus 5 over 2. That's my point, and all I have to do now is I just have to simplify this down. All right, so I got negative 10 divided by 2, that's negative 5. And then I got 8 divided by 2, that's 4. Okay, so make sure you remember your negatives. Negative plus a negative makes a bigger negative, which is why we get negative 10 here. All right, we'll wrap it up there, and next time we'll do distance formula.